Hello and welcome back. In the last session, we looked at data persistence in Docker. We also looked at the different storage options that are available when we talk about the data persistence. So we have volumes, we have bind mounts, and we have the Tmpfs mounts. And we also looked at why we need volumes. Now it's time to get our hands dirty and see how to use them. We are going to persist a real database step by step. We will cover the two main flags for mounting storage, the -v flag and the -mount flag. We will learn how to manage our volumes with the Docker volume command, and we will put it all together by making sure our data survives even when our container doesn't. Now, before we dive into the details, if you found this content helpful, please hit that subscribe button. It really helps the channel grow and allows me to keep making more videos just like this one. Let's get started with this. First, let's talk about the syntax. Docker gives us two primary ways to attach a volume or bind mount to a container. The classic -v flag and the more explicit -mount flag. Let's start with the one you will most often see in examples, the -v or --volume flag. It's very concise. The basic syntax is -v source colon destination colon options. For a named volume, if you want to mount a volume called my underscore volume to the slash data directory inside the container, we would run this command. So docker run -v and then the name of your volume, the path inside your container, and then the name of your image. It's short, it's simple, and it works. But notice the syntax is a bit stringly typed. Everything is crammed into one single string, which can get messy with complex options. Now let's look at the newer kid on the block, which is your -mount flag. The -mount flag was introduced to be more explicit and easier to read. Its syntax is a list of key value pairs. The same command from before would look like this. So docker run -mount and then it has your key value pair. So type is the type of storage, your source, your target, and the name of your image. So why would we use -mount if it's more verbose? There are a few reasons for this. One is your explicitness. It's very clear which part does what. Type can be volume, bind, or TMPFS. Source is the volume name or host path. Target is the path in the container. There's no guessing. No magic behavior. If you're using the -v flag and if you don't specify a source, Docker will automatically create an anonymous volume. With -mount, you must specify everything, which prevents accidental anonymous volume creations. And lastly, easier for complex scenarios. When you start adding read-only options or volume driver options, the -mount syntax remains clean and parsable. The general consensus is that -mount is the better practice for scripts and Docker files because it's more predictable. For this session, I will be using both so you can recognize them, but I want you to understand why -mount is often the recommended choice. Now, before we run our database, let's get familiar with how to manage volumes directly. We have a suite of Docker volume commands for this. First, you can explicitly create a volume. This isn't strictly necessary as Docker will create it for you when you run a container, but it's good to know. So the command for creating a volume would be docker volume create and then the name of your volume. You can call it whatever you want, and this will create a volume for us. Great. Now let's list all the volumes Docker is managing on our system. So for that we can use this docker volume ls command, and at this point we have created only one volume, and that is what I can see here. So here you can see our new volume, my underscore app underscore data. Notice its driver is local. So Docker supports other drivers for cloud storage, but local is the default. Finally, we can inspect a volume to get all its details, where it's actually stored on the host, when it was created, and more. So I can use this docker volume inspect, and then our volume name, and this will give as to when this was created, what is the driver type, and all those things. Now look at this mount point field. This is the actual directory on the Docker host where the data is stored. So on a Linux host, this is the typical path. This is Docker's managed area. We don't need to touch this directly, but it's good to know where our data lives. All right, the moment of truth. Let's run a PostgreSQL database and make sure our data is persistent. We will do it twice. First, without a volume to see the failure, and then with a volume to see it succeeded. So let's start a Postgres container without any volume. I will be using this -f rm flag, so it cleans up completely when it stops. So docker run -f rm, let's give it a name. So this will be my ephemeral db. We will set our PostgreSQL password, and let's say I'll just give some dummy password for now, and then our image name. So here, if you notice, I've not used any volume. So let's run this, and this will start a new container for us. So it is downloading the image. So let's wait for this to complete. Great. So my database container is running. Now I will open up a second terminal here, and let me connect to the same instance. So here I should be able to see my Postgres container. Now let's connect to this and create a database. So docker exec-it, that's my container ID, and then PSQL -u Postgres. So I am inside the container and I'm connected to the database. So this is my PSQL prompt. Let's create a database called important data. So create database, and let's call this as important data. Let's list the database to confirm it's there. So /l, and looks like it's not there. So let me try this once again. So here you can see it says create database. So this was completed. Now let's list the database, and here I have the database. Perfect, it's there. Now let's simulate a container failure. So we will go back to our first terminal here, and we will stop the container using Control C. You can see, and now because we have used this -rm flag in the docker run command, the container will now be gone. So here, let me show this. Let me clear the screen. So docker ps, and you can see the container is gone. Now let's start a new one exactly the same way. Okay, whatever we did earlier. So this will again start a new container for us, and here you can see the container is ready to accept connections, and I should be able to see the container here. And let me try connecting to this database. So it and PSQL -u Postgres, and let's try listing the database, and you will see that it's gone. Our important underscore data database has vanished into the digital ether. This is the ephemeral problem we talked about. So as long as the container is running, the data would be available. If you stop or remove the container, the data is gone, and that's the default one. This is where we can make use of your volumes. So let's fix this. So we will stop this container. So let me use this Control C, which will stop the container. So again, because I've used this -rm flag, the container will be deleted. Now we will run a new one, but this time we will use a named volume to persist the data in your var lib PostgreSQL data, which is the default data directory for Postgres. We will use the hyphen mount flag for clarity, and we will call our volume as pg underscore data. So here, this is the command. So docker run, again I'm using -rm, I'm giving it a name, I'm setting my password, and then here you can see I'm using the mount to make my data persistent. So we're using the volume type, I'm setting my source on my local machine, this is my path inside the container, and then the image. Notice here, if you don't have this, Docker will automatically create this volume for us if it does not exist. Now let me run this, and in our second terminal we will go ahead and create the same database again. So here I should be able to see the new container again. Let me connect to this. So docker exec -it, and I'm inside my database. Now let's create our database here, and we will call this as important data, and my database is created. Let's list the database, and here is my database. Now for the real test, let's go back to the first terminal, and we will stop this container by using this control C command. The container will be removed. So here you can see the container is gone, but our volume remains. Let's confirm the volume if it is still there or not by using this docker volume ls command, and here you can see I still have the volume. Now let's start a brand new container, but we will point it to the same volume. So essentially it's going to be the same command. So I'm just telling it to use this volume which is already existing. So let's start a new container again. So you can see the container is started, and let me go to the new terminal here, and I should be able to see the container, and let's connect to the same container here. So exec PSQL, Postgres. So I'm inside the container, and now I should be able to see my data intact. And there you have it. Our important underscore database has survived the destruction and recreation of its container. This is data persistence in action. This is how you run stateful applications like databases in container. You can now update your database image, restart your server, or move this volume to another host, and your data remains safe and sound. So because now I have my data stored inside this volume, even if I start a new container, I can point to the same volume, and whatever the data I had is persistent. And no matter if I kill this container or start a new container, my data would still be available. This is your volumes in action. Now let's talk about bind mounts. Perfect for development workflows. Imagine we are building a Node.js application. So I'll kill this. So here I have this node app folder, and within this I have my package.json and then app.js. So within this package.json, this is what I have this in my GitHub repo. I will share a link to this so you can refer the same thing. So this is my app.js where I'm just returning some output, and this is the package.json that we have. So create this, and we will be using this with the bind mount so we can develop live. So once you have these files, we will now start a new container. So docker run -d, let's say this is my dev server. We will do the port mapping because this is going to be an application, and then we will use our mount. Type is going to be bind. Source is going to be my present working directory. My target is going to be /app. My working directory is going to be /app, and then the image. And then I'm also gonna run some commands here. So npm install ampersand npx nodemon app.js. So here, this is the command. Again, these commands are available here within this particular file. So this is what I'm using. So you can use the same thing. Now, before you run this command, or rather, yeah, before you run this command, there's one more thing that we will need to do, which is we will need to install this save dev node mon. I'll tell you why this is needed in some time. So go ahead and install that. If you don't have npm, then you need to install that first. So this is done, and now we will start our container. So let me take that. Okay, so looks like I already have it. Yeah, so let me remove this. I'll stop this. Now I will remove it, and I will start the container once again, and this should start a new container for me. So notice how I'm using this mount type as bind and not volume. So this is basically telling Docker that I want to use a bind mount for my container. So the container is created. Now let's test our application. So I'll use this localhost colon 3000, and you can see hello from container version 3. So basically whatever you had in your app.js, it is printing it. Now here's the power of your bind mount. So if you remember the last session, I explained that bind mounts can be used for your development purpose. So we are essentially, what we are doing here is we are creating a two-way mirror by using the bind mount. What that means is, if I modify the source code in my host machine, the same will be updated within my container path, right? So let's look at this as an example. So what I'll do is I'll open up this app.js, and let's say we'll call this as version 4, and let's say this is the updated version. I'll save this file, and we will test this again. We are not doing anything else. On my local machine, I have updated my app.js, and now we are just gonna hit the URL once again, and you can see my code is also updated. Now this is coming from my container machine. All right, so no need to restart the container. Now how is this happening? This is because of the package, this one nodemon that we installed. It is because of that. Now, if you don't want to do this, the other way that you have is you can restart the container. So every time you update your code on the local machine, if you want that to be updated within the container, you can simply do this. So docker container, docker restart, and then your container. This will update the code on the container it also. Now if you don't want to do this, that's where we make use of your nodemon, which will automatically update the code for us inside the container as well. So this is the power of your bind mounts. The changes are immediately reflected. This is why bind mounts are essential for development. You get instant feedback without required to rebuild your container. So it creates a two-way mirror. You can also update the code inside the container, and that will also update the code on your host machine as well. So as you can see here now, like let's say again, I will update. So let's say this is another update, and again if I do a curl, I should be able to see that change. So that's the power of your bind mount. Finally, let's look at TMPFS mounts for sensitive non-persistent data. Let's run a container that handles sensitive operations. Maybe it processes authentication tokens or temporary session data. So let's say docker run -d. Let's give this a name. So let's say secure processor, and the mount type is going to be tmpfs. Target is going to be /app slash temp secrets, and then the name of the image, and then my command. So this should start a new container for me over here. Again, you can notice that the type here I'm using is tmpfs. This basically tells docker that now I want to use tmpfs mount for the container. Now let's create some sensitive data. So docker exec within this container, and maybe let's say sh-c echo, and we will write this to /app slash temp secrets slash token.txt. And now let's do a cat of this so that we can see that we have the data. So cat, and I have the data inside the container. Great. Our application can read and write to this directly normally, but here's the key difference. This data is stored only in memory. Let's prove it. First, let's find where volumes would normally be stored, but for TMPFS. So for that, we can run this command. So docker exec, our container name, and then mount grep for tmpfs, and here you can see this is the mount that we created, but for tmpfs. So this basically tells me that my data is stored in memory only. Now let's stop the container. So docker stop, and then the container name, and I will remove this container. So let's remove this, and the data is completely gone. There's no volume to clean up. So here you can see there's no volume to clean up. No data is left on disk. This makes TMPFS mounts perfect for session caches, temporary API tokens, SSL certificate processing, any data too sensitive for disk persistent. So let's recap our three storage types in practice. So we have the named volumes, perfect for production data that needs to survive containers, managed by Docker, portable and reliable. Then we have the bind mount, ideal for development, syncs host directories with containers for instant feedback, tied to specific host path. And then you have the TMPFS mount, best for sensitive temporary data, stored only in memory and vanishes when the container is stopped. This is great for secrets and caches. Each has its own purposes, and now you know how to use all these three effectively in your Docker projects. So to summarize what we did, we saw the problem by running a database without a volume. We learned the -v and more explicit -hyphen mount flags. We used Docker volume commands to manage our volumes. We achieved true data persistent by mounting a named volume to our database's data directory. You are now equipped to tame the ephemeral nature of containers. Go forth and persist your data. And that brings us to the end of this session. In the next session, we are going to deep dive into Docker networking. We will look at the default networks that we have, and we will also look at how containers communicate on the same network. If you found this session helpful, please hit that like button, subscribe to the channel for more content, and let me know in the comment section if you have any queries. Thank you for watching, and I will see you in the next session.